Hi there, and welcome to yet another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to continue on our study of systems of equations, and we're going to be looking at how to solve systems of equations by substitution. In the previous lesson, we looked at how to solve a system of equations by graphing. So if you haven't watched those videos yet, or you haven't worked with systems of equations by graphing, I suggest you go back because we're going to start off this lesson with graphing a system of equations before we go into solving by substitution. So in algebra, the solution is not always going to be an integer. So we will need to know how to solve systems using other methods as well. So today we're going to learn how to solve systems of equations by substitution. So let's begin with the following systems of linear equations: y equals negative 2x plus 5 and y equals 3 over 2x. Let's graph them. Let's see what happens where they intersect. So we have y equals negative 2x plus 5 has a y-intercept of 5 right there. And we're going to go down 2, right 1, down 2, right 1, down 2, right 1. And we're going down 2 because we have a slope that's negative 2. We continue to do that for as far as we can on this graph. I don't have a line there, so I'm not going to put a point down there. Then I'm going to go in the reverse direction, which means up 2, left 1, until I have all of my possible points that fit on that graph. And I'm going to go ahead and I'm going to draw a line through those points and put arrows on either side to show that that line goes on forever. I'm also going to label that line as y equals negative 2, x plus 5. Now I'll choose blue, and I'll graph this line in blue. Y equals 3/2 x, and that's really plus 0. So that means I have a y-intercept of 0. It's going to go through the origin. And I'm going to go up 3 over 2, up 3 over 2, up 3 over 2. And then I'm going to continue that pattern in the opposite direction where I go down 3, left 2, down 3, left 2. And again, those are all the points that fit perfectly. So I'm going to go ahead and connect these points now with a straight line. On that straight line, I will go ahead and put arrows and label it as y equals 3 over 2x. Again, all of this is review from lesson number 1 when we solve systems by graphing, because it leads to this question right here. Where is the intersection point? Well, let's take a look. Our intersection point is right here. Simple enough, right? Well, we don't know the exact value. We might want to be tempted to say that it's 1.5 because it's in between 1 and 2. But that would be guessing, because it might be 1.49, it might be 1.48, it might be 1.501. We don't know the exact value of the intersection point, so we can't guess and say what it is. We need to find an alternate method to find the value of that intersection point. So our intersection point is not an integer value. It's going to be a decimal value, and we have to find that exact value. And we're going to try to do that by solving the system using the substitution method. So it says since y is equal to negative 2x plus 5, because we have y is equal to negative 2x plus 5, it says substitute negative 2x plus 5 in for y in the second equation. So our second equation was y equals 3 over 2x. So we know that y over here is the same thing as negative 2x plus 5. So it's saying substitute it in for y right there, because we know y is the same thing as this. So we can rewrite it as negative 2x plus 5 is equal to 3 over 2x. And now solve for the exact value of x. So we have to get all of our x's to one side of the equation. I'm going to do that by adding 2x. I'm going to get 5 is equal to, well, 1.5x plus 2x is going to give me 3.5x. And if I want to go ahead and I want to divide that by 3.5, I'm going to get 5 divided by 3.5 is going to give me some crazy long decimal. So what I want to do is I want to make this a fraction, okay? So how can I make 5 over 3.5 a fraction? because x is going to be 5 over 3.5. But again, we can't have decimals in our fraction. That doesn't make any sense. So we have to make this a fraction. So we can make this a fraction by, let's double both the numerator and the denominator, and we get 10 over 7. And if you put 10 over 7 in your calculators, you're going to get the same answer that you got when you divided 5 divided by 3.5. And it says the exact value of x. So if you were to write a decimal answer, since that decimal is a repeating, very long repeating decimal, trust me, it is repeating, but since it's so long, if you were to round that decimal, you wouldn't be giving the exact value, you'd be giving the rounded value. So the exact value of x is 10 over 7. And we would have never guessed that from looking at this graph right here. We were saying that it was 1.5, which is not the same as 10 over 7. We were off. So that's why we do not estimate from a graph. We use another method when we're not given an integer value. So now that we have that x coordinate, we want to substitute it in to find the y coordinate. And when we substitute it in, as we've seen in previous lessons, this x value will make both equations true. So you could choose either equation to find the y value. So I'm going to substitute it into y equals negative 2x plus 5. I'm going to go y equals negative 2 times 10 over 7 plus 5. And I'm going to go ahead and I'm going to get negative 20 over 7 plus 5. And if I want to go ahead and do that in my calculator, I'm going to get y is negative 20 over 7, 5. To get that that's going to be 35 over 7. And that's going to give me a solution of 15 over 7. So again, you might have looked at this graph and saw that, oh, well, it looks like it's at exactly 2, but this is not at exactly 2. This is actually a little bit larger than at 2. So the solution to this system that we would have never guessed from looking at that graph was 10 over 7, comma 15 over 7. And that there, ladies and gentlemen, is why we don't estimate in math. We attend to precision and we look for precise answers. And we do that by using these various methods that we're going to be learning on solving systems of equations. We've now looked at graphing and our first exercise on solving by substitution. And if this video was helpful in seeing how you solve by substitution, give the video a thumbs up and you're ready for exercise number 2, where we're going to solve a couple more systems using the substitution method. Thank you for watching.